Hey everyone, this is lesson 5.8. We're going to be talking about graphing linear equations with your x and y intercepts. Okay, so this is the third method of the series of methods that I've been teaching you in class about how to draw a straight line, so a linear equation on a graph. Now, in lesson 5.5, we had talked about probably the slowest method, which is using a table of values. And so a table of values, you're going to have a set of x values, you're then going to calculate your y values, and hopefully that gives you about 5 points that you're going to graph onto the grid and join with a ruler. And again, fingers crossed that everything is in a nice straight line. Now, yesterday in class, lesson 5.7, I had taught you about a much faster way, which was a slope-intercept method. And that's where you use your y-intercept first as a starting point on your y-axis. And then you're going to use your slope, which is your rise, and then your run in order to draw another point. And you're going to join those 2 points together with a straight line. And there you go, that's your line. So that's a lot faster. I'm going to leave it up to you to decide whether or not you like this third method, and that's, if it's faster or slower than these other two methods. Okay, so I'm going to have to first talk about what x and y intercepts are, and that's written right here, but I'm going to explain it with this diagram. So pretend that this is your line, your graph with the arrows. And so an x-intercept is where your graph intercepts or cuts through the x-axis. And I just put a number of 2 as an example, okay? And so this coordinate right here is going to be 2 and a 0. Now, any coordinate along the x-axis, so no matter where your graph cuts this x-axis, always has a y value of 0. It might change with the x value, but it's always going to have a 0 in for the y. With the y-intercept, which is a coordinate where your graph intercepts or cuts through the y-axis, you're going to have a random number. In this case, I decided to put a 3. That number is going to go at the back as your y value, but your x value is always going to be a 0. And why is that? Because no matter where your graph cuts into the y-axis, all of these dots along the y-axis all have an x value of 0. So here's a way to always remember it. If you're looking for the y-intercept, your x is 0. If you're looking for the x-intercept, your y is 0. Now, once you have those 2 dots, you just join them with the ruler, and that's it. You're done. Okay, so let me show you how that works. Okay, so here's our example. Find the 2 intercepts, your x and y intercept, and then graph. So with your equation that you're trying to graph, it's going to graph a straight line. You're going to find the x-intercept and y-intercept, and then put them both onto the graph, join them with a ruler, and that's it. And so let me go through the actual calculations now. Remember, if you're looking for the x-intercept, your y is 0. You're going to be solving for your x. So notice that at the very end, your answer has an x. If you're looking for the y-intercept, your x is 0, and you're looking for the y. So notice that at the end, you have a y answer. Okay, so let's look at this one a little bit more closely. When your y is 0, you write out your equation right here. You stick a 0 in for your y in brackets, which means that it's going to multiply the number in front of it. So 2 times 0 is just 0, and a 0, who cares about it? You just cross it out. It's not there. There's nothing there. Not important. So the only thing that's important over here is your x. And the only thing left over here is your 6, and therefore that's the answer. X is 6. Your coordinate is 6, 0. 6, 0 is right here. In other words, your x-axis, put a dot at 6, right there. Okay? Now over here, if you're looking for your y-intercept, you write out your equation right here, see? Instead of an x, you're going to put a 0. Now again, the 0 is not important, so cross it out. The only stuff left is the 2y equals to 6. Okay, and that's easy to solve. You're just going to divide both sides by 2. You get the answer of 3. So your coordinate is 0, 3, which is right here. Or you can think of it as on your y-axis, put a dot at the 3. So there you go right there. You have both your dots join them with a line, but don't just join like from here to here, like join all the way across, like use up your entire grid. Put arrows on both sides because this line goes on forever, and then also label it just in case you're drawing several lines on the same graph. Okay, so I'm just going to go really quickly now through the second one so that we can move on. This is the x-intercept. If you're looking for the x-intercept, rewrite your equation and stick a 0 in for your y. 3 times 0 is going to disappear. The only thing left is your 4x minus 12 equals to 0. Now you're going to start solving for your x, so move everything away to the other side. That's going to become a positive 12. It was a negative 12 before. Divide both sides by 4 and you're going to get a 3. So on the x-axis, put a dot at 3. If you're looking for the y-intercept, rewrite the equation but put an x value of 0. 4 times 0 is not important, cross it out. Only thing left is going to be 3y minus 12 equals to 0, and so start solving for your y now. Move the negative 12 to the other side, it's going to become a positive, and divide both sides by 3, you're going to get a 4. So on your y-axis, put a dot at 4. Join them together with a ruler, make it nice and long, and then put arrows at the ends and label it. That's it. So what do you think of the third method? Easier or harder than the other ones? Your choice. Okay, your opinion. All right, moving on to the next concept. So I'm going to apply what we've learned to linear inequalities. We've never really touched upon that, inequalities, and it's actually kind of new to the grade 9 D stream curriculum. So this is an equal sign right here, right? And that's what we're normally used to. But in inequalities, let me just scroll down. Sorry, this is supposed to say inequalities. It's talking about these symbols. So these symbols are called inequalities, and you're probably familiar with them. Like this one's called greater than, that one's called less than, this one is greater than or equal to, so that's what this line underneath is called, is the equal to, and this one is less than or equal to because of that line. Now, these represent a series of numbers or range of numbers. So in this case, this number could be anything that is greater than, say, 2. Okay, so remember that the number that is the bigger number is going to go on this. See how it kind of looks like a mouth, right? It's going to go on the side of the mouth. So it almost looks like the mouth is eating the bigger one. The smaller number goes on the side of the little point, the pointy part. Okay, so 5 is greater than 2, 1 is less than 4. But this number could be like a whole range of numbers because there's lots of numbers that are less than 4. So when we put a variable on one side, it represents all the possibility of numbers that could possibly be bigger than 1. So say like 2 or 5 or 100 or a million. But it could also equal to 1. See that little line right there? So x could also be 1. And again, y could be a whole range of numbers less than or equal to 3. So when we talk about using these inequalities in a linear fashion, what we're doing is we're still graphing straight lines as we were doing before, except we're now, since we're talking about a range of numbers, we're shading one side of the graph or the other because it actually means it includes all the entire field of those numbers. So that's a little bit confusing, I know. Let's go through the steps and I'll kind of show you. So graph the line first of all. So you need this border line, this boundary line, and we graph it like we would normally graph a line. Now, depending on if this line is solid or dotted, it really depends on your inequality symbol. So if your inequality has a line underneath, it's going to be a solid line because it includes all the dots, the coordinates along the line. But if there is no equal sign underneath, it means it does not include any of those coordinates as well. Then you're going to shade either above or below or to the left or the right of that boundary line. I think it's just easier to explain through examples. So here are 3 examples. Notice that each of the equations look kind of like equations we've dealt with before, but instead of an equal sign, we now have an inequality symbol. Okay, so if there's an equal sign underneath, like a line underneath, you're going to be drawing a solid line. If there's no line underneath, it's going to be a dotted line. And so notice this one has a line underneath, so I draw a solid line. But how do you draw that line? We'd gone through several techniques before about how to draw linear equations. And so you kind of just pretend that this is an equal sign. So I wrote it over here with an equal sign, and you graph it the way that you have graphed in the past. And so this particular question looked like it would be easiest just to use a slope and y-intercept. So starting with the y-intercept of -7, put a dot there, and then using your rise over your run, 4 over 1, to go up forward over 1 to put another dot, and then connecting them. Still put the arrows and still label, but the third thing you now have to do is shade one of the sides of like one of the boundaries. And the way that you do that is pick any coordinate on either side. And I picked 0, 0 because it's the easiest. And put both the 0 and the 0, your x and your y, into the equation. And so when I did that, I put a 0 in here, and 4 times 0, sorry, I kind of got cut off, -7. All of that, when I calculate it, is equal to -7. So the 0, 0 is kind of like a checking point. If it works, I shade this side. If it doesn't work, I shade this side. So I want to know if 0, 0 is included in that boundary. When I subbed it into my equation, I got a -7 on this side. 0 is actually a number that is greater than -7, so this works. If it works, 0, 0 must be part of the solution for this inequality, which means I shade this side. If it actually didn't make sense as a statement, I would shade the other side. Okay, so you always have to do this check. Now, really quickly, this is a vertical line at 3. And so we're going to go x is 3, which is right here. Dotted line, because again, the inequality is just a less than symbol, not a less than or greater than, or sorry, less than or equal to. And now to know which side to shade, you're going to pick a coordinate. And so I always like to pick 0, 0, as long as it's not on the line. 0, 0 is just easy numbers to deal with. And so checking with 0, 0, you take your x of 0, your y of 0, and you sub it into this equation. So notice there is no y. There's only an x. So I'm going to put a 0 in right here. Is 0 less than 3? Yes, it is. And so 0, 0 actually works in this inequality, which means that I'm going to shade the side that 0, 0 is on. Okay, let's try that one more time. Now that I've taught you the x and y intercept method, I'm going to use, and it's the x and y intercept method is actually really good for any equations that are in standard form, not in like slope intercept form. It's actually faster to use in standard form. And so I'm not going to go through it, but you can look at my math. I use the x-intercept at 8, the y-intercept at 4 to draw my line. It's solid because the inequality had an equal to symbol right at the bottom. And then I'm just going to do my check with 0, 0. So 0, 0, this origin is right here. And if it works, I'm going to shade in the side with the 0, 0. If it doesn't work, I'm going to shade in the other side. And so with the x is 0, y is 0, I'm going to put both of those into the original equation. 3 times 0 plus 6 times 0 is going to give me a 0 on this side. On the other side, it's going to be a 24. So does this statement actually make sense? Is 0 less than 24? Yes, it is. And so 0, 0 makes sense in terms of this equation. I'm going to shade in the side with 0, 0. Okay, so that entire lesson, this video, is basically on this one last method of how to draw a straight line, although we kind of went over many different methods with this example, and then we applied that to inequalities. So if you have any questions, which I'm sure, some are still bubbling around, feel free to message on this video, or if you are my own kids, my own students, you guys can email me. Hope you have a great day.